As we discussed, project management processes are organized into 5 process groups. Each is a logical cluster of related processes: initiating, planning, executing, monitoring and controlling, and closing processes. Process groups are, by intention, not discrete. They overlap over the course of a project life cycle. Initiating processes drive the preliminary interactions of a project and typically begin to drop off as the project moves toward planning processes. As initiating processes complete, planning processes ramp up and involve interactions with the executing and monitoring and controlling processing groups as deliverables are being developed. Executing processes are within the next process group, and executing processes occur throughout the project life cycle. Just like the prior processes, executing processes tend to pick up as initiating processes end. When execution peaks, planning processes slow down. Monitoring and controlling processes are active through all project life cycles and peak when execution activities peak. Closing processes begin after initiating processes end. When planning processes are completed, closing process group activities increase and peak as execution processes draw to a close and are the final processes within a project. At project initiation, there are activities within the initiating process groups, but not much activity in the other groups. While a project progresses, the initiating activities draw down and activities within the planning, executing, and monitoring and controlling process groups pick up. At the end of the project lifecycle, the activity concentration moves to closing processes, and there are minimal activities that continue within the prior process groups. Keep in mind that process groups are not the same as project phases. Process groups represent the types of phases that take place within a project. Within each process group, there are the phases that a project must go through, like planning, for instance. Large projects typically consist of many phases, like feasibility, design, and construction. All process groups are required within each project phase, so therefore, the feasibility phase would require initiating, planning, executing, and closing processes. The same would be needed for design and construction on an iterative basis. Process groups intentionally overlap throughout the project's life cycle. One constant element of almost every project is the probability of change. Change activities relevant to planning, executing, and monitoring and controlling are iterative in nature, and when changes occur, the processes need to be applied to the changes as if they were part of the original project. It's important to remember that when one process experiences a change, that change will most likely impact other processes. This is due to the interconnectivity that exists between processes. Assume that you have been asked to add an unplanned component to a project. This component will require additional time to complete, which will push out the delivery date of the project. Suffice it to say, the project's schedule will be impacted, and that impact will have residual impacts on other processes. The project schedule is an output of the develop schedule process, which in turn feeds the control schedule process, the estimate cost process, the budget process, and the procurement process. Additionally, certain aspects of the project occur across process groups. Quality processes, as an example, take place within planning, executing, and monitoring and control, with quality-aligned processes within each process group that collectively permit quality imperatives to be planned, actioned, and monitored through the life cycle of the project. These processes, plan quality, perform quality assurance, and perform quality control, make up the project quality knowledge area. Quality is one of the knowledge areas where each respective knowledge area concentrates efforts that are similar in nature to respective project activities. For instance, the project integration knowledge area spans all 5 process groups and promotes processes that will be used within the project's life cycle to drive the project from inception to closure. Keep in mind that risk and potential for negative impacts to the project schedule can occur whenever there are dependencies. Think about it. If a process input is delayed, there is a good chance that the delay could carry forward and impact the output of that process, which in turn could impact the project schedule, or at the very least require the project manager and team to consider methods to make up time so the project's critical path is not impacted. We discussed dependencies and the inherent impacts that can be attributed to delays in processes that drive project work. Let's take a look at a similar project impact when change is integrated into the project. It has been said that the one constant that a project manager can rely upon is change. The fact that change happens in some way, shape, or form should not be a surprise to any project manager. In fact, it should be expected and in most cases planned for. So how can a project manager plan for a change when they have no idea what the change may be? The answer is in the form of organizational process assets. Process assets provide a mechanism to formally accept change, integrate change in a way that minimizes the impact, promotes an approval process, and maximizes the value of the change. Organizational process templates provide for change request forms that formally create a change request that requires approval. Approval in the form of a technical or feasibility review, as well as financial review that would commit funds to accommodate the cost of the change. Project change requests are typically reviewed by a change control committee that is made up of subject matter experts and project team members that determine if the risk-reward ratio is worth integrating a change into the ongoing project. If a change is not approved, considerations may take place to drive change activities in a separate project, or there may be no action at all. If a change is accepted, the change needs to be retrofitted into the project, and all project processes used to develop components of the project will now apply to what needs to be developed within the change. Additionally, all project management plans and subsidiary plans will require updates as well as review of the impact of the project's critical path. While change at times may be necessary, it is important for the project manager and team to realize why the change is required and what the change means relative to the overall project deliverable. The question should be raised: can the project be completed successfully without implementing the change? If the answer is no, then the processes to perform integrated change control should be initiated to properly engage formal change management activities. A good project management practice is to keep changes to a minimum. A project that is subject to multiple change requests may be an indicator that the project is in jeopardy or the project manager and team did not do an effective job in determining project requirements within the planning stages of the project. Let's take a look at an example. Suppose you are the project manager commissioned to oversee the construction of a house. Assume that the project initiation activities have taken place and planning is underway to develop a 5,000 square foot home on an acre of land. The parcel of land has been surveyed and architects have delivered the blueprints with the specifications to build the house. You are on your way. 3 major requirements are: the house is a log cabin design that will use logs from a local mill, the house must be built within 3 months to avoid winter weather, and the budget for the house cannot exceed $500,000. 2 months into the project, the sponsor wins the lottery and wants to double the size of the house to 10,000 square feet and keep the same project timeframes. A change like this can have implications across the project. Obviously, the scope of the project has practically doubled, so scope management processes are impacted. Requirements for the new layout will need revised blueprints and update to all plans. An update to the project's work breakdown structure would be needed, and that update would impact the project schedule and the project's critical path. Remember, the original deliverable was 3 months, and there was only 1 month left if you were to stick to the original plan. If you were the project manager, what would you do? Obviously, it would take some negotiations with the sponsor, the local mill, and the project team. Suppose the mill did not have enough raw materials available to meet the revised plan. You may need to compromise and bring in materials from another source, which in turn could impact the project budget. Again, it is obvious that additional human resources would be required if it were, in fact, feasible to double the size of the project within the remaining 30 days, which in turn would also impact the project budget. At this point, the one thing that you as a project manager must remember is that the work you perform is the analysis of all the alternatives. One good practice would be to use expert judgment and collaborate with project team to develop scenarios, say good, better, best, whereby the sponsor can make the decision on the alternative that meets his needs and falls within the project constraints. In this case, a good recommendation might be to continue to build the house as is and move in according to plan. A better recommendation might be to finish the existing project as per the original plan and sell that house. Use those proceeds for an even bigger house under another project at another time. The best scenario might be to place the project on hold until the winter season is over and provide ample time to develop revised plans and update the project so realistic timeframes and deliverables can be managed. Under the best scenario recommendation, the project manager is exercising his authority to stop or place the project on hold until it can be managed properly. It provides the best alternative for the project manager and will better meet the needs of the sponsor without incorporating risk into project deliverables. The one drawback, however, is the concession the sponsor will need to make in regard to time, being that the project for the new home cannot meet present expectations. A good project manager needs to be able to communicate, negotiate, and manage all stakeholders, including the sponsor.